And I haven't had anybody really have trouble getting in or out. Yeah, I'll post it on the website, and I'll let everybody know that it's going to be virtual and stuff like that too, so it'll all be up there. All right, last 9 topics. So some of these are word problems, some of them are not. The first one happens to be a word problem. So it says Ravi is putting money into a savings account. He starts with $650 in the savings account, and each week he adds $40. So we're going to let S represent the total amount of money in the savings account, and W represents the number of weeks he's been adding it. We want to write our equation. So when you're looking at this problem, this is your y equals mx plus b, your simple slope-intercept form equation. So write that down. So y equals mx plus b. So now we're going to plug the information in. So in this case, my slope is my slope to 40 or the 650. Which one's going to be changing? The 40. Every week he's doing 40. So it's 40. And weeks was W, right? So that's W. And he started with, yeah, that's separate. That right there is for this part here, not the equation. But good catch. So yeah, so this one's 650, and then it's S is my total amount of money. So my equation for yes. So apparently, well, my laptop did. Okay, but it never actually dropped out of there, so I'm not worried about it. All right. So we're now looking at 16 weeks. So that's the first answer. So now we're going to plug in 16. So S equals 40 times 16 plus 650. So 40 times 16 is 640 plus 650 is 1290. And that's the money answer there. So on this topic, you're going to come up with the equation and then plug a number into it. You're not going to get you're not going to get that part right either. Any questions with that one? Okay. All right. This one we've actually done. I think we've done this topic actually already, but it's not a bad thing to actually go over it again. It was in the last one too. Apparently it's in multiple sections in the book, so it keeps coming up.
So for the equation,
no, it's fine. You type in S equals 40W plus 650. No. Nope. The equation is without the 16. So this one says Joe is putting money into a checking account. Let Y represent the total amount of money in the account. X is going to represent the number of weeks. So my equation they gave you is Y equals 40X plus 450. They want to know what is the change per week in the amount of money in the account. So which number represents the change? 40, that's my slope. So that's 40. Okay, so that's my M or my slope, that's the change. And then what was the starting amount of money? That's the 450. So that's my B, my y-intercept, or the starting. That's it. That's all this question's asking. So as I said, it's like there's all this stuff there. It makes it look really, really complicated, and nope, That's all it's asking. So. All right. Questions with that one? All right, so let's do some graphing ones now. All right, so we've done some graphing ones before. This one's similar, except there's one slight change to it. So on this one, so this one, they don't give you your y-intercept. So all the ones that we've done with graphing so far has given us the y-intercept and then given us the slope. This one, they don't give me the y-intercept. They're giving me a point. Guess what? It doesn't matter. It's the same steps. Because to do your slope, you just need a starting point. Doesn't really matter where it is. It's simple when it's on the y-intercept or the y-axis, but it doesn't have to be. So 5, 2. So I'm going to graph 5, 2. So I'm going to go over to 5 and up 2. And I put a point right there. And now from there, I'm going to do my slope. My slope is -1 over 3. So down 1 and over 3. Yep. What do you mean? To the right, correct. So here's why. And I'll actually show you. Let me actually draw them. So we're going, so the top is my rise, which is up if it's positive and down if it's negative. Okay? Okay. The bottom is my run, which is right is positive and left is negative. Okay? Which is what you were thinking. Problem is if I went down, what's the negative over a negative? Positive, right? So that one can't be negative if I've already done the negative. So the nice thing and the reason why what I'm normally always saying this is if you do your rise first, if you go up or down first, you take care of the negative sign, you're always running to the right. You never have to run to the left. The only time you will ever have to run to the left is if you run out of room on your graph. And then you want to do everything completely backwards. You want to move the negative sign down the bottom to do it. But that's rare. Yes, that's very, very common mistake. So yeah, the negative sign, even if it's out in front, only goes to one of the numbers. We just always put it at the top. So a very good question, a very good clarifying answer. So that's good. Actually, let's do one more of those. Ooh, this is a good one. All right, so this one, my point is -2, -4. So I'm going to go -2, -4. So I put my point right there. Now, what's my slope in this case? My slope is -1. And since it's a whole number, it's always over what? Always over 1. So I'm going to go down 1 and over 1. And there would be my line. Okay. So yeah, any whole numbers are always over 1. Yeah, I'm just copying and pasting from Alex. I just figured instead of switching back and forth because there was like the word problems and a lot longer things, so it's easier to copy and paste tonight. All right. Okay. So now the next one, this one right here. What's the format that problem's in? So there's three formats that we've looked at. Okay. So we've got slope-intercept, which is the y equals mx plus b. We've got standard, which is the ax plus by equals c. So we're all the letters on one side. And then we got point slope, which was the y minus y1 equals m x minus x1. Those are the three different formats that we looked at on these. So, no, that wasn't what this question is asking. So I was asking a question that it wasn't actually asking. I wanted you to notice that was in the point slope format. What they wanted in is they wanted in standard form. So we've got to take it and move it over to the other format. The problem is with this is a lot of times we translate it to slope intercept form instead. Okay, and that's what I didn't want you guys to, that's why I wanted you to understand the difference between the three of them so you can see it, because it's very common. Normally we always go to slope intercept form, and this one they want in standard form. So we need to do a little extra work for it. So it's okay. It's nothing horrible, nothing that's going to be that insanely hard to figure out. All right, so when we look at this one, so we've got the y plus 5 equals -2 parentheses x minus 4. So what's the first step do you think we want to do? Yep, so let's get rid of that parenthesis. So y plus 5 equals -2x plus 8. Don't forget to multiply that -2 times the -4. Very, very common mistake. People forget to do that all the time, and you will get the answer wrong. Huh? Sorry, I don't draw that well. It's okay. There you go. Is that a better 5 for you? It's fine. All right, so what's the next step I want to do? Yeah, let's move the 5 over. So actually, the reason why I showed you this is because what we're going to end up doing is slope-intercept form. So -2x plus 3. The 5 was already there. Yeah, and then I'm just subtracting from both sides. So this is now in what form? This is in slope-intercept form. We wanted it in standard form. So I need to move the 2x over to the other side now. So I now have y equals -2x plus 3. I need to move this 2x over to the side. So we're going to add 2x to both sides. So I have 2x plus y equals 3. And that is the answer they wanted. Okay. So that was why I wanted to show you the three formats, because there's three different ways we can write these equations. They're all equally accurate and give us information. You just got to make sure you get the proper one the way they want it. Yeah, well, the nice thing is they don't tell you standard form. They don't say put it in standard form. They wrote it. They wrote the ax plus by equals c, so it kind of gives you that hint. So it's not that hard. You don't have to remember necessarily the names. The key is making sure that the x and the y are on the same side in that respect. So, and don't stop when the y is by itself, which we all want to do all the time, because that's the goal, because that's function notation. That's literally where we normally work with. So standard form works really well with the x and y intercepts. That's why we use standard form. Yeah. Oh yeah. Yeah, and honestly, that's a lot of things in math. It's like if you have a true math person, they're going to use the terminology a lot. It's the vocabulary, and if you don't have the vocabulary, you're going to be totally, utterly lost. Yeah, it's like you're going to be totally lost. So it's like that's why yes, I'm stressing the vocabulary so you know it because I know you're going to have those teachers, but it's also knowing how to use them, which is the more important piece in the end. All right, so now this one, another reason why I wanted to show you the point slope form. This is wants it in point slope form. Okay, so it says point slope form. So remember, point slope form is y minus y1 equals m x minus x1. So in this problem, they gave me all the information I need. My m is -3/4, and my point is 8, -5. So that's x1, and that's y1. So now we're just going to plug right into that problem. So y minus a -5 equals -3/4, x minus 8. So the only thing you have to do is change that to a plus, because I have two negatives. So the final answer is y plus 5 equals -3/4, x minus 8. And you're leaving it just like that. That's point slope form.
I feel like we need more of these.
How do I know if I'm going to use the 5 or the 8 first? I labeled them right here. Oh, remember, points are always x, y. So your x is first, your y is second. That's why I labeled them there before I plugged them in. You want me to do another one of these? Sure. I gotta put the answer in so I don't get it wrong, and it's easier, it's faster for me. It's not a comma, it's a 1. It's y1 and x1. Think about like the slope formula. Remember, it's x1, it's y1 or y2 minus y1 over x2 minus x1. Those are ones, not commas. There's a little dot that I have to hit when I grab this, and I can't grab the dot. There we go. Okay. So line passes through point -8, 6, and has a slope of 5/4. So take a second, write me the equation, and then I will do it. All right, so my m is 5/4. My point is x1, y1. So y minus y1 equals m. X minus x1. So I have y minus 6 equals 5/4. X minus a -8. So it's x plus 8. So, because it was minus and a negative. So that's why normally when I'm doing, and I didn't do it on this one, I'll normally write like that. So don't lose your sign. And then basically that just becomes your positive because two negatives. Which step did you mix up on?
I don't know.
Okay.
Where it says y minus y1.
Yep.
And below it.
So the y stays the same. The y and the x is going to stay. So the y1 comes from right here.
Yep.
So that's the 6. So that's the 6. And then the x1.
First x stays.
And then, yeah,
The
and then that's there.
And because that's minus and minus. It's like,
That's how you get the positive. Yep. All right, I'm going to look at a couple pattern problems. So when you're looking at these problems, in essence, what you're looking for is you're looking for slope first. Okay. So we're going to look for slope. Slope is, and I'm going to show you a symbol that you're going to see quite often in other math classes. That little triangle stands for delta, which means change. So the change in the output over the change in the input. So it's the same thing as saying y2 minus y1 over x2 minus x1, because that in essence is your y, and that is in essence your x. Okay, yeah. Okay, good. I don't want it yet. Answers don't help with steps. All right, so now we're looking for the change. So we're going to look for how far is it changing from 8 to 24. What's that changing at? So it's 24 minus 8. That's 16. Okay. What's 32 minus 24? 8. Okay. So now we're going to do the same thing up top. What's 6 minus 2? 4. 6 minus 8, or 8 minus 6 is 2. Okay, so we've got our change. Are they the same? No. Okay, so they don't look the same yet. So the next thing we want to do is we're actually going to do the division on them to see if they do come out to be the same. So if they don't come out to be the same, this is not linear. We cannot do this process. It's something else. I will tell you all these topics are going to come out the same because they are linear. Otherwise, you can't do it. But so all we're going to do. Yeah. So 16 divided by 4 is 4. And 8 divided by 2 is 4. So my change or my slope is 4. Okay? Does that make sense? Okay. Step 2. We have to see if anything else is added or subtracted from it. This one's easy. We just actually try. What's 2 times 4? 8. What's 6 times 4? 24, and 8 times 4 is 32, right? So my answer is just 4 times n. Okay.
so if that n was an actual number.
Right.
Okay.
Because that's what I did to the other 3 things. I multiply each one of them by 4. 2 times 4 is 8. 6 times 4 is.
Things that are on Facebook too.
Yep, these are those wonderful patterns that drive people nuts. Okay, so you find your slope, and then we try it. The next one we're going to do, we're going to have to do an extra. We'll have to add or subtract to it. That's why there's 2 topics. There's one that's 1 step, and there's one that's 2 steps. The 1-step one, you don't have to worry about it. The 2-step ones, you do. But instead of teaching you 2 different processes, because they're in essence the exact same thing, I'm doing it to both. So, but yeah, it's looking for patterns and then coming up with an equation for that pattern. All right, so we're gonna do the same thing to this one. First thing we do is find my slope. So 11 to 15 is what? 4. 15 to 19 is? 19 to 23 is? 4. 1 to 2 is 1. 2 to 3 is 1. 3 to 4 is 1. Hey, this one works out nice. It's the same thing. So we only have to do it once. Remember, big piece, output over input. So my slope is 4 over 1, or 4. Okay, remember it's the output over the input. Okay. So now we got to try. What's 4 times 1? 4, but I wanted 11. Right? So it's 4 times 1 plus 7. So give me the 11, right? Okay, so 4 times 2 is 8 plus 7 would give me the 15, right? 4 times 3 is 12 plus 7 would give me 19. 4 times 4 plus 7 is 23, right? You good with all those? So the next one is 4 times n plus 7 is my answer. Notice all I did is I just changed the number to an n. So 4n plus 7. And don't use x,
really
use
quick
n.
before you-
I'm going to do another one.
You did the
But yeah.
4 plus 1.
No, 4 times 1.
And you added the 7.
Because I wanted to get to 11. I needed to get to 11.
Get that first.
It's the first one, correct. Yep. And then once you got the first one, you try it on the second one. If it doesn't work on the second one, then something's wrong. Okay. If it works on the second one, odds are it's going to keep working. And you don't have to do them all. Like you didn't have to do the 1, 2, 3, 4. Like that, I just did that to show you it works. What you really want once you realize pattern is just go right and just change the number to an n. So. Let's do another one of these. All right. I'll make it a little bigger for you. Take a second and try it. I swear I'm going to make it bigger for you. There you go. So your slope, your change is 2. The output's always 2, the input's always 1, so it's 2 over 1, which is 2. Okay. So now I've got 2 times 1 plus something equals 0. So 2 times 1 is what? 2, but I want 0. So what do I got to do? So minus 2. That'll give me 0, right? Okay, now let's see if it works on the rest. 2 times 2 minus 2. 2 times 2 is 4. Minus 2 is 2. So that works. 2 times 3 minus 2 is 6 minus 2 is 4. So it works. So 2n minus 2 is my answer. I didn't have to do it. You could. It'll come out to be the same. 2 times 4 is 8. Minus 2 is 6. The key is like you're looking for the pattern. So once you find the pattern, put it. You're done. So I do a couple of them just to check and make sure you're not wrong.
That you have the right pattern.
Yeah, because like if it works for a couple but then doesn't work, especially with zeros and ones, like those numbers, you can get things that work really well for those but don't work anywhere else. That's why when we normally tell you to test things, we don't tell you not to use zeros and ones because you can get things wrong. But once you get up to like the 3 and stuff like that, if it's working, odds are it's going to keep working. So you don't have to do them all. The answer they wanted was 2n minus 2, nothing else. All right. 2 more topics, 2 oddball topics, actually. There we go. Okay. And the questions. So in this topic, they're giving you different representations of a linear function. So a linear function can be represented 4 different ways. It can be represented as a graph. It can be represented as a table. It can be represented as an equation, or it can be represented in words. Okay, it's known as the rule of 4. It can, any kind of problem you can represent in 4 different ways. They've got all 4 representations. They're not all the exact same. So don't assume that they're all the same because they're not in this case. We need information. Then they're going to ask me some questions about them. So it says, which graph is the least steep? Which I hate the way they worded that. Which function's graph is the least steep? So least means small, right? Okay. So what's the slope of the first one? So this one, we now got to basically have to figure out my slopes, right? So what's the slope of this first one over here? Okay, make it a little bigger. So we went up by what? 1, 2, 3, 4, 5, and over by 1. So my slope for this one is 5. Slope for 3 is 2. Slope for 4 is -1, right? Slope for 2, we're going to do what we just did a minute ago. So we're going up by 1 here, right? It looks like this whole side's going up by 1s, right? 1, 1, yeah. So what's this side going up by?
What's going up by 1?
-2 to -1 is positive, is +1, right?
Oh, yes.
So this side's going up by +1, every one. So -+1 is that one, -1 plus 1 is 0, 0 plus 1 is 1. So the change over on this side is 1. What's the change on this side? 8 to 5 is -3, right? We're going down by 3. So my 5 minus 3 is 2, 2 minus 3 is -1, so this whole side's -3. So my slope is what? Which one goes on top, the -3 or the 1? which value is on top of my slope? The rise, right? Which is my which value, x or y? The y. So it's -3 over 1, which is -3. Okay, so my slopes. So my slopes 5, 2, -3, and -1. Those are my slopes. So the least steep. So least steep.
Is it asking what the least, basically the smallest change is?
Yes, it's actually, if it was asking what the smallest change was, believe it or not, it actually would be -3. Because -3 is actually the lowest number. And that's kind of why they asked it the way they did. And this is why I hate the way they asked the question. What they're asking for is the closest to 0. Because -3 down is pretty steep. Okay? 5 up is pretty steep. 2 up is less steep, right? -1 down is the least steep. It's the closest to 0. So when they're talking about least steep, they're looking for the slope that's closest to 0. So the easiest one to walk. Okay? Which would be flat surface, which is exactly 0. So in this case, my least steep slope is function 4. Which of the functions have graphs with slopes less than -2? Function 4 has a slope of -1, right? Is that less than -2? So the only one is function 2 with the -3. Now the last one says, which function has the graph with the greatest y-intercept? So function 1, the y-intercept was 4, right? What's function 2's y-intercept? Where is it at 0? So remember, the y-intercept is where the x is 0, right? So what's the y-intercept for function 2? 2. It's where x is 0. So that right there, that's my b. That's my y-intercept. What's the y-intercept for function 3? -5. So that's my b. And this one they gave you, it's -1. So which one has the highest? Function 1, the 4. Okay. Just be happy I did the test before I saw this topic. Oh, that was your. Because I actually like this topic, but because I think it really actually makes you think, but it's not on the test. You're welcome. Yeah, it's because it makes you really think about them all, but no, it's not on the test. It will be on the test for my freshmen, though, because I'm going to make them do this because I really like this topic now. So my freshmen can blame you guys.
So any of your freshman tutoring?
Huh?
Any of your freshman tutoring? If they're already learning this, I feel like my son.
I have the honors freshman classes, so yeah, they're actually working on this in Algebra 1. All right, last one. I would do more of those topics, but I think that one's honestly one you just literally have to try yourself and go through it. Those will be one of those topics at the end that you may not finish. It's okay. All right. Okay. Now, so this topic is asking about independent and dependent variables. Okay. Independent and dependent variables. I think I mentioned it before, but I might not have, but it's very simple. Your independent are your X values. Those are your inputs. That's stuff you know. So remember when we did the functions, it was the question was at when you ask a question, that's your independent variable. That's the thing you're asking. Your dependent variable is the answer you're going to get, which is typically your outputs or your Y's. So in this problem, a used car dealer is examining how the price of a car can be sold varies on its mileage. What's the dependent variable? So the question is, which is the thing that you would know ahead of time? Would you know the mileage of the car or the price of the car? From the dealer's perspective. They're using the mileage to figure out the price, right? So it says the price of the car varies with the car's mileage. So they know the car's mileage when it comes in, and they price the car according to the mileage. Okay? So the price is dependent on the mileage. Okay? So in this case, my price is my dependent variable. Okay? When they give you the equation ones, it's easy. Function relates the input U to the output Q. Which is the independent variable? Is it U or Q? Independent is what? The input or the output? Right. So they're asking for independent. The input is U. Yeah, those ones are easy. It's the word problem ones that are the real life ones that are the paid ones. Carla has a part-time job entering data in a computer. The amount of data she enters affects the pay at the end of the week. What is the independent variable? Is the independent variable her pay or the amount of data she entered? So here's another way you can think about it.
No,
does the
dependent on the amount of
right? So does the pay depend on the data, or does the data depend on the pay? The pay depends on your data, right? So then your pay is your dependent variable because that's the one that depends on it. So that means in this case, my amount of my data is my independent. Because that's what they're asking. So independent is what you start with. So if you're going along the week, you're entering data, right? And at the end of the week, your boss says, how much data did you enter? Okay, here's your paycheck. That paycheck depended on how much work you did. Okay? A lot of times on this one, they'll say, like, your pay depends on how many hours you work. That's typically what it is, right? Unless you're a contractor, and then it depends on how much work you do. But normally it's how many hours you work. So your pay, money typically is always your dependent thing because it always depends on something else. Time is typically always independent because time always moves in one direction. Oh, independent is your input. It's the question you ask, and dependent is your output or the answer to that question. No problem. So yeah, time's typically always independent. Money's typically always dependent because money always depends on something else.
Yeah.
So there's like I could say like
Chapter 3.
yeah, this is the end of chapter 3. So it's like I go to the store and I buy X amount of cereal boxes. Is the independent variable the money that I have or how many cereal boxes I bought? In that case, money is the independent variable because this is the number of cereal boxes I can buy depends on how much money I have in my pocket. So it's like the rule of money is always dependent and time is always independent. There is some flexibility there. It's just normally the case. So, okay. All right. So we did decide that next Tuesday's class will be virtual. Great. That stays. I will put the link on there, and I'll post it up there like probably the Monday. So this way everybody remembers that it's virtual. Saves me the hassle of running down after my staff meeting that goes till 4 o'clock. So that'll work out nice. Tuesday is the review for the test, yes. And Thursday is the actual test. So I'm going to have I'm not recording. I will not post the review for the test. Okay, I'm telling you that right now. I'm not going to post the video review for the test.
In other words, you get.
Oh, so you can do,
Yeah, I get it.
Okay, so we will, because I'm basically going to do the test with different numbers, but I'm basically doing the test. So I'm not going to post the review for the test.
Because if you post it, it's like a cheat sheet.
Correct. So, true, but it's,
You don't know how to do it.
however, the review test is up already online, so you're more than welcome to do that as many times as you want to practice for it. So, okay? I will see you in person Thursday. I'll see you online Tuesday. I will have to say that is one nice thing that came out of the pandemic. The
I didn't know why they
option.
weren't doing this before, honestly.
It's like,
I
yeah.
had friends that were getting out of school so late because of snow days and stuff, and
Yeah.
I was like, why are we not doing this online?
Yeah, it's like the
But
option
then
of
they're like,
having,
"Hush," because they
Some
have to
people-
go in anyway half the time, and
some people like to ski.
yeah.
I had one teacher who goes, you can't take away my snow days. We're not going to be able to go skiing. I'm like, your skiing, our summer vacation.
Right, yeah.
I'm taking our summer vacation over you going skiing. Go skiing on the weekend.
Have a good weekend.
You too. It's actually kind of cool. My new district, I haven't had an actual February vacation in